Hello YouTube, Rohan this side. So in today's video, I will be creating a demonstration video on Helm Charts. So if you are a DevOps engineer and working in deployment and release management, then you may be already aware of this amazing software or what we can say uh, tool. So Helm is a package manager for Kubernetes. So Kubernetes use Helm for deploying the charts of the applications which we work in our companies. So you can consider Helm as a package manager like we have APT and Yum and Brew in Linux and Mac OS. So Helm works similar like that and Helm install the packages and the charts. Basically the charts which we have created by ourselves or maybe which are created by many any other user or any other corporate. Okay, so this is the official web page or website of Helm, where you can see how they have described Helm. So Helm is the best way to find, share, and use software built for Kubernetes because Helm basically is used in Kubernetes cluster to deploy applications. And so this is the definition of Helm. Helm helps you manage Kubernetes application. So it provides Helm charts, which defines and install and upgrade. Means we can perform these many actions using Helm charts here, and it also comes under CNCF, and it's a graduated project. So we can much rely on Helm, and so if you are new to the Helm, so you can consider this as a Docker. If you are familiar with Docker, so in Docker also, you know that we have a software or what we can say an application, and using Docker we containerize or Dockerize it in lightweight using Docker files or Docker Compose YAML files. So Helm uses the same concept of compressing or what we can say in zipping our all YAML manifest, which is related to the application and which runs the application. So manifest can be anything like the deployment, service, config maps, secrets, and the list goes on. You can add any number of manifest file, and you can even deploy, or you can also use the concept of registry or artifacts, which resembles like Docker Hub. So I think we can check the artifact of Helm as well because it's the official artifact tree website which Helm supports, and where we can also get the charts of other people as well because we can distribute our application to any user, and we can also deploy the same in any environment we have. So this is the CLI command to install Helm in different operating systems using different package managers we have. And let's check where it's artifact. I have to check the charts. Okay, yeah. So this is artifacthub.io. Here you can check other Helm charts or projects which other users have created. So below the page, you can see that we can also install Helm charts of Elasticsearch, Pylon, MyIP, and many more. So today in our video, we will be creating Helm chart from scratch, and we will deploy the same in our Kubernetes cluster as well. Okay, so let's go to the installation page or the box. Yeah, okay, and the quick start. Well, okay, to install Helm. first we should have a Kubernetes cluster because it supports Kubernetes cluster, and there only we have to install Helm. And to install Helm in our Kubernetes cluster, we just have to use these three commands, which I have already mentioned in the GitHub repository, which I will be using in our demonstration video. So this using the homebrew chocolatey windows, you can also install Helm, which we have already seen in just few minutes back. So this is how you can install Helm, and to check Helm commands here. These are the Helm commands, which for using which we can create our chart. We we can deploy, we can install, and we can even delete, and many more things we can do. So we will definitely check these commands in our next videos if time permits me. And okay, so I think let's directly jump to the demonstration section we have. So this is the GitHub repository which I am using. I will definitely share the link in the description. So let's first create our Kubernetes cluster. So in this video also I will be using Kilocoda. Let's create this cluster of Kubernetes version 1.29. Okay, so just to install Helm, we have to first install, we have to just run these CLI commands in our Kubernetes cluster. And you can also check if Helm is correctly installed or not. So using this command, I think we can check if Helm is correctly installed in our cluster or not. Uh, I guess let me check it again. Sorry, I missed the curl command here. Let's do it again. Yeah, so you can see that Helm is installed correctly, and this is the version which we are using. The install, and it's the latest. Okay, so to just basically create a Helm chart, we just have to write Helm. I think Helm create Helm chart. So this is a demo chart, and so this is Helm, and this is create any new chart in our Kubernetes cluster. My chart is the name of the chart which I'm providing, so you can give it any. Let's create. Okay, so creating my chart. I think it's created. Let's go into our chart. So here you can see that it has created uh, two files and two directories. So this is the architecture of Helm, which provide us default templates and default file structures when we install or create a new chart, new Helm chart. So let's go and explore what they are storing. Let's first check the chart YAML. So the chart.yaml is nothing but kind of a description of our chart, and it's mostly hard-coded value, or if we are releasing any new version or new release of our application, so we just have to change few things of this file. So mostly the content of this file is API version, the name of the chart, so which we have already given in the previous like previous section, or what we can say in a few minutes back, which we have given. This is the description, which is also a default description. These are the commands. This is the version. We can change it any whenever in the future we will be releasing any application. And this is the app version, so we can change this as well. So basically, in short, chart.yaml just contains the default values of version and the application name and the chart name and the description. Okay, so let's go to the charts. CD, okay, CD charts. So CD chart, it's a blank directory. So this directory usually stores sub Helm charts. Suppose if we have multiple Helm charts and they are interrelated with a parent chart, so uh, we can we can mention them in this directory. So currently this is blank because Helm does not provide any default sub Helm charts. So it's empty, but we can fill it or like use it uh, according to the project we have. Okay, so now let's check the CD templates directory we are in. So this is important directory which stores our manifest file of the application. So as you can see that deployment, ingress, service account, helpers, HPA, service YAML. So these are the common YAML manifest file in the Kubernetes cluster for deploying the application. So using Helm, we don't have to write anything from the scratch. We are given with predefined values of or predefined structure of the manifest file, which can saves a lot of time, and we can even customize it accordingly to our requirements, and we can even delete this. So you can definitely check what contents they have already like written inside this. So it's a huge file, and you can check that it is following the same structure which we follow in writing the deployment YAML. And here you can see the braces, which is having some variables, or we can get to know when I will be doing the demonstration. Like after just few minutes. So currently you will be confused like what is written in this uh, key value pairs. So these are nothing but uh, the values which are like fetched from the values.yaml, which is written inside the same directory. Yeah, in the home directory, we can say. So this is the structure of the deployment.yaml. Same case with all the YAML files we have here. So yeah, let's check the last thing. So values.yaml. So values.yaml is a manifest file which is storing all the values which we will be using in our deployment or any manifest file which is inside the template. So suppose we have a deployment where we need three replicas. So what we can do is we can hardcode the value of our replicas into this manifest file, and we can just fetch the value of the replicas inside the templates and inside the deployment at Gap. We will definitely be doing a good or beginner level of demo so that you can uh, have a basic understanding of how Helms is working using this architecture. So let's check what is inside the in Windows table. So here you can see it is having okay, so it is having the values which we use in our YAML manifest files. So here you can see this is the replica count which is given one here. This is the repository. So default Helm creates a Nginx repository, means it use Nginx as image. This is the pull policy which is if not present. Same case if you are very much familiar with writing deployment and service and ingress and other things of manifest file, so you will easily understand what are these values, and how they are related to the manifest file, which is inside the templates. So this section is for the service account. We have given the default values here, and we can definitely see that it has also uh, created the section for service, the type we want to use for our service to get exposed. This is the port which we are using, and this is for the ingress. This is for the resources. This is for the props we have. This is for the HPA, and many more. Like you can uh, add any number of values, any number of uh, like manifest file in the templates. Means you can just create your own package and compress it and reuse it, redistribute it to other users as well or other projects as well. So this is the structure of the Helm, which it provides when we use Helm create command, and these things are in default. Okay, so in the video, so in the demonstration, I will be not using this structure. Means I will be using this structure, but I have created my own Helm chart, which is already pushed to my GitHub repository. So I will just refresh this, and it will give me a new Kubernetes cluster of my favorite Kubernetes cluster. So now I will reinstall Helm here. Installing, yeah, installed. It's cloning this repository, git clone. Okay, so it's inside Helm app. So here you can see this is my root. This is my root directory, and I'm inside it. Okay, so here you can see that the structure which I have already shown you in the default Kubernetes Helm chart. So I'm also following the same, but you may notice that I'm not using charts directly here because I have not written any sub Helm charts for this project. So we can ignore it, and we can simply delete this because uh, we can we have the flexibility to add things and delete things in the chart. Okay, so let me first go through uh, the directories and the files which I have written here. So let's go with chart.yaml. So in the chart.yaml, you can see that the same thing I have been using, which is given by the default creation command, the helm. So I have not changed anything here. This is the API version, name, description of this, and the type is application, version, and everything. So this is a not a very uh, important file, but yeah, but if in your projects you can definitely add more things, and you can uh, take this more seriously, like by adding the correct version and the correct description of your application. This is uh, what this chart.yaml meant for, a kind of your introduction or metadata. Okay, so let's go to the values.yaml. So in this values.yaml file, I have given the values of replicas I want in my application and in the dev section. So in this project, I am using two images in which first we'll be using dev. Maybe means that I have just replicated two images which works like it is installed in dev environment, and another one is installed in prod environment. So you can just like think like that with the video in the throughout the video that we are having two applications. One is for dev and one is for prod. Okay, so let's go to the templates, which is important. part of this demo video. So I have created two manifest file for dev environment and two for prod. And for dev, one is deployment.yaml and another is service. Same case with prod, one is deployment and another is service. So let's go with dev deployment. So it is following the same structure which any deployment Kubernetes client will follow. Only difference is that now we are fetching the values of the fields from values.yaml. So the important thing while defining or using the values from values.yaml, uh, that the things will inside double braces here, and the parent or the root directory means like whenever we are fetching any value, we have to use dot capital V values. If you will use lowercase v, then it won't work. So please remember that it should be always in uppercase, and then we can follow anything we want. So if I go by example that in the name, what I have written is dot values dot dev dot name. So if I go to the values dot YAML here, so dot values is the name of this values file, and dev and the name. So and using that path values dot dev dot name, we are fetching the values of the name. So in our case, it is dev. So this is how we can follow the path to fetch the values. And the same case for replicas, I have done is dot values dot replicas, and in the values.yaml manifest, you can see replicas is three here. So this is how you can define okay the things in your YAML manifest file, and you can hardcode or use values.yaml. So in this demonstration video, I have given I'm using dev for my name of this deployment, and the match labels and the selectors for my container, and this is and for my name of the container and the image I'm using. So here you can see that in the image, this is my image where I'm using the value of dev, and in prod slash deployment.yaml, this is the value which is in different, which is different with the value I have given in my dev deployment and service manifest file. So this is how I can differentiate the values so that I can use different keys and values in my other manifest file as well, and I can define the same in a single values.yaml file. So here you can see it's a simple manifest file, and I have used the single value of uh, my uh, my name many times in the manifest file. So in the demonstration video, we will try to create a variable uh, which we will first declare the value in our values.yaml, and then we will uh, rectify the same. Sorry, we will modify our deployments and other manifest file so that you can have a better idea like how the things are working. Because demonstration definitely clears our thinking, and it also generates the curiosity of modifying and customizing things. So these are the simple manifest file. Here also you can see I'm using the name which I've declared in manifest file. Okay, so I think I was clear with the demonstration, like with the overview of the GitHub repository which I have created for Helm Charts. Okay, so let's go to the readme.md. So we have not used Helm create because we have already created the Helm chart structure. So now what we will do, we will just simply use this. We will go back to the root directory, and just run this command. So here you can see that Helm install my first app release, my app. So what it has done, it has installed the new release of my app. So my first app hyphen release, you can give this any name, whatever you like. So it has given the name of my release as my first hyphen release. Last deployed means it's the current date, and the namespace it has taken is default because in the manifest file I have not given any namespace. And status is deployed. This is a revision, and the test suite is none because inside my templates I have not given any test because it was not needed for this demo. So now we can even check like if everything is working fine or not using kubectl get all. So here you can see I have 6 pods, and 3 pods are for for the dev application and 3 for prod application. So if you remember that in our values.yaml we have given the replicas value of replica value is 3. So this is how it has created three pods of each environment or region, you can say. This is the service for my application. So let's check if they are accessible or not. So first let's check for the dev. Okay, this is the port access. So here you can see the message welcome to dev. Now the same thing we have to check for the prod if it is accessible or not. Paste this. So here you can see welcome to prod application is also working. Welcome to dev as well. So here you can see that our application is deployed. Both applications working fine. Okay, now the interesting thing. Let's modify and create some new fields in our templates. So let's go to the template section. So what I'm thinking to create two different namespaces in which our application will be deployed. So what I'm thinking for the dev, all the pods and the service related to it should work only in dev namespace, and for the prod, it should work inside the prod namespace only. So let's go. So let's check the values. Okay, sorry. So I've created things like that. Whatever I will be doing inside dev will be implemented for the dev and for the prod as well. Means the same case goes with the prod. You can also like give any kind of hierarchy you want to give in your project. So I'm just going with this. I'm giving the value of my namespace as dev-region. Let us go with this dev ns because it should be some different, and this is prod ns. So now you can see that the structure in the templates should go like that: prod dot namespace. So like how we have given the values for the name inside the manifest, it should goes the same for the namespace as well. So let's go there first, save this. Yeah, so this is how it's looking: prod and namespace. Let's go to the templates section. First, let's create those namespace as well, because maybe in the hand we will forget to create the namespaces, and we will run around some errors. Okay, let's change it, and let's start with the deployment.yaml. So namespace usually comes inside metadata, and let us this name space. We will use the same thing, but instead of name, we have to mention namespace. It's done. Now do the same for the service. Again, we have to go inside the metadata. Namespace. Okay, sorry. Namespace. So then this. Fine. Let us copy this because we have to use the same for the prod as well. The only difference we have to add is, instead of values.dev, now we have to use prod, because the value of the namespace for prod was stored inside the prod section of values.yaml. If you are following the video, you can easily understand like what I'm trying to convey here. Same, I have to check or modify in my service for the prod as well. Change it to the prod. So we have successfully modified the manifest file. Now let's get back to the root, because we have to upgrade our Helm chart, or you can say the release. We have modified the release. So using Helm upgrade command, we can upgrade the things, and we can explicitly mention flag of values, like what things we have like modified from the previous version. So my first app hyphen release is my release name. This is the package name or the chart name, and hyphen hyphen values. My app is giving the path that here the values is stored, and we have modified it. So let's enter this command. So here you can see that release, my first app hyphen release has been upgraded, and this is the last deployed date. Namespace is default. Status is deployed, and this is the division it has created. Okay, now let's check if things are working or not. Okay, kubectl get all. So here you can see that using all, we are not able to see the pods which we were able to see earlier. See, no pods are running in default namespace. Why? Because we have shifted the dev pods in dev-ns namespace, and the pods and other stuff in prod-ns. So let us create two tab here so that we can parallelly check the pods and all. Let's go with this -n dev sinus. So here you can see that now we can check the pod for dev application is running inside DevNS. Now let's do the same for the pod as well. Oh, sorry. See, the pod for the prod application is also working fine. This is the service. So if I refresh this web page, then I won't be able to see welcome to prod message because service and other things have been reconfigured, and it has been allocated with new values of other ports. So okay, let's access them. If we are able to access the service, uh, okay. So this is for dev, and for the prod, we are given with port 31055. Let's check this. So here you can see we have easily deployed the application to their respective namespaces as well, and everything is working fine. So this is the beauty of Helm, that you can package your application which is running inside Kubernetes cluster. So we can like compress and package the manifest file into one, and we can also push uh, the packages or the charts to this central repository so that it can be easily reusable by other users, by other teammates, by other and other projects as well. And because Helm provides much flexibility, so uh, we can even use others Helm chart as well. I hope I was able to clear the doubts which every beginner uh, face using Helm, because Helm seems a little bit complex, but using this simple demo video or the demo application which I have created in my GitHub repo, you can definitely jump, and you can definitely try using the same in your own local cluster. And I will be happy if you will customize it more, because I have not customized it more, and I've been using the same values in almost most of the fields. So it would be nice if you can go and modify other things. You can even add ingress in the same directory. You can use other deployment as well. You can add things for other uh, environment as well. You can add other features for the deployment as well. Okay, so thank you for having me here, and I hope you will definitely uh, like the video and create more content uh, by yourself using help. And thank you.